Okay, in this video, I'm going to do an example problem. Well, it's not quite an example problem, but I will take up a problem that is on the homework and provide some hints on how to solve it. Okay, so let's look at the problem. The problem says the voltage across a 5 microfarad capacitor is given to be this guy for t greater than or equals to 0. Okay, find the current through the capacitor, as it were, for t greater than or equals to 0, for t greater than 0, and what is the power at the terminals of a capacitance when t equals to 80 microseconds. Okay, in reality, the current does not go through the capacitor, but it goes around, it is displaced around the terminals of the capacitor, but it can be thought of as going through the capacitance for all intents and purposes. Okay, but in reality, that's not the case. That's beside the point. But we have found ourselves in this situation in the past. Okay, you see, a capacitance value is given here, and the voltage value is given, and current we are supposed to find I equals to C dV by dt, right? So that is the formula that we can use when we are given a value for C, an expression for V. We should be able to calculate. That is something we have done in the past, right? So I'm not going to elaborate this. Go back to the inductors, the very first example that we did. You see, in the inductor problem, I is given, expression for I is given, and L is given. We were supposed to find V. Here, V is given. We should be able to find dV by dt. C is given, and then that should give us. So mathematically speaking, it's still a derivative. Okay, so I'm going to leave it there with a little bit more, insight, perhaps. Okay, so we have seen and solved this problem, similar problem already. So what you have to do is, in order to find the capacitance, the current through the capacitance, or the current displaced around the terminals of the capacitor, you plug in a value for C, which is 5 microhenry. Okay, and the derivative of your voltage. What is your voltage again? 500 T e to the minus 2500 T. Okay, 500 T multiplied by e to the negative 2500 T. Okay, so we use the chain rule, and then because it is a composite function, and then you should be able to solve this problem. Okay, I will leave it as an exercise to you. Let me show you, let me give you some hint on how to solve the power. The next part, power. Okay, what did we do in the previous example problems when we have to do the power calculation? Let me go back here. Okay, when we had to do the power calculation, power absorbed or delivered, when did we do this? In the example problem 1, in order to do the power absorbed or delivered, what we had to do was to find the value for voltage, find the value for current, multiply them for that given, find the value of voltage for that time and the current for that time, multiply those instantaneous values. Okay, so in order to find the power, what we have to do is, well, we can go back and use one of these formulas as well. Okay, let us see. Where did I give you the expression for power? Okay, when we were summarizing, the idea of capacitances, I said you can multiply voltage and current, or you can do CV dV by dt. Okay, so we can use that guy as well, CV dV by dt. because V is given, okay? An expression for V is given. Um, you should be able to calculate dV by dt. In reality, all of this in the pink is nothing but that guy is really I. Okay, so that guy is really I. You're multiplying I with V. So you can use either of these formulas to calculate the power. Okay, so let us do it this way. Let us calculate the voltage across a capacitance at t equals to 80 microseconds. Okay, what you do is to plug in t equals to 80 microsecond in the expression. Okay, in the expression, that's this guy. Okay, so you should be able to calculate some value for this volts. Okay, then there is I of C at t equals to 80 microseconds. So I'm going to not solve the problem entirely for you or give you the numbers, but I'm going to show you that once you solve this derivative and get an expression for I of C, plug in a value of t equals to 80 microseconds into that expression, and the final answer for power that you should see when you multiply V of C and I of C really at time t equals to 80 microseconds is 53.626 microwatt. Okay, so because we have solved a very similar problem in the past using derivatives, and because um, you're comfortable doing the problem, I'm not going to show you the individual steps, but I still have shown you the approach that you should use when you are encountered with this kind of problem. In the next video, we'll look at more examples.